welcome to Python Pop, a series of quick videos where I explain different Python functions and commands. And in today's video, we're going to be going over something that was requested, adding two-dimensional vectors, but not just adding them, also visualizing them. So let's get started. In order to visualize, we're going to need some sort of plot. So let's go ahead and import matplotlib.pyplot, and we're going to import that as PLT. Now, in order to even start with adding these vectors or visualizing them, we need vectors themselves. So let's create a vector v1 and set it as, it's a two-dimensional vector, so it just has an I and j component. So for v1, we're going to make those components 2, 3. So there's our vector v1 is 2, 3. And remember, vectors have direction and magnitude. So when we're plotting this, if a vector has a direction and a magnitude, we need to specify its starting location or its tail. So we're going to say that our origin or our starting location of the tail is going to be at 0, 0, because what I want to do is visualize this on the XY coordinate system. So let's start that tail at 0, 0. Now we're going to set up our plot. So fig, ax, we're going to set those as plt.subplots. From there, let's go ahead and graph our vector v1. And we graph these vectors. If we want the arrow on the head of the vector, we're going to say ax.quiver. Now again, a vector is direction and magnitude. So we need to give its tail a starting location, which we set as the origin. So origin 0, origin 1 is the location on my XY coordinate system where I want that tail to start. And then after that, a vector, direction and magnitude. So I'm just going to put my v1 of 0. So that's for the I component, and v1 of 1, that's going to be that j component. And since we're plotting these in 2D, we're going to be using the XY coordinate system. So we need to set our angles and scale accordingly. So we're going to say angles is equal to XY, that string, and then also our scale units is going to equal the XY string. And we want that scale value to simply be 1. So scale equals 1. Let's go ahead and show this plot. So plt.show, open and close those parentheses, and let's run this cell. And here's our vector, but it goes off of our coordinate system. So we need to go back and set our x and y limits. And we do so by ax.set_x limit. Then we're going to give the x values a minimum and maximum. So let's start with -1 and go up to a maximum of, let's say, 5. Because I know that setting this vector where its tail is at the origin, the tail is going to start at 0, 0 and go to the point 2, 3. So I know I'm not going to surpass 5, and let's do that same for the y values. So ax.setYlim is also going to be from -1 to 5. Now when we run this, there we have our vector v1 starting at our origin 0, 0 and going in that direction where if our tail is 0, 0, the head is going to be at the point 2, 3. Now we want to show adding vectors, so we need another vector. Let's set a vector v2. And v2, let's make it just in that y direction. So we're going to do our I component as 0 and our j component as 5. So in order to distinguish between vector 1 and vector 2, I'm going to add some color to this vector. And I'm going to set the color of v1 as blue. And we're going to copy this line and change it up to fit our vector v2. So I'm going to switch all my v1s to v2s, and I'm going to change the color to, let's say, green. And because we're starting again at the origin and vectors have direction and magnitude, the head of this vector is actually going to be at 0, 5. So I want to extend this y limit slightly so that we can capture that entire vector. Let's go ahead and run this. So there we have our vector v1 is now in blue. We extended our axis, and there is our vector 0, 5, that green vector. So let's think about adding these vectors. When we add vectors, we add the I components together and we add the j components together. So our resultant vector, which I'll call r, is going to be equal to the sum of v1 and v2, adding the I components together and the j components together. So now you can easily write a function for this, but since I chose easy numbers to work with, I'm just going to do this in my head. So those I components, 2 plus 0 is going to be 2, and those j components, 3 plus 5, is going to be 8. Now I want to plot r. So I'm going to copy the code that plots the vector, change my original v1 or v2, whichever one I copied, to be r, and let's make that resultant color red. Again, now you can see that our y limit has to be at least a maximum of 8, but this 2 still falls into our x limit, so I'm going to change my scale now for y to go up to a maximum of 10. Now when I run this, making sure to run the previous cell, now when I run this, you can see there's my resultant vector. But it's kind of hard to picture the addition of these vectors. You can kind of see and draw it out. If I started with my blue vector v1 and then went straight up, I would indeed end at this vector here. But if we want to look at the addition of vectors, maybe we shouldn't start both at the origin. So let's copy this code and paste it in the cell below. So we're going to get the same exact figure, except now I want to show taking v1 and adding v2 to my vector v1. Again, vector has direction and magnitude. So just as opposed to starting my vector v2 at the origin, if I want to see that added on to v1, I'm going to set my v1 as that starting point, because starting v1 at the origin and going its direction and magnitude, I know that the head starting at 0, 0 is going to fall at the point 2, 3. So I'm going to start at that point 2, 3 by pasting in v1, 0 and v1, 1 instead of origin 0 and origin 1. I want my vector v2, the tail, to start where the head of my first vector finished, but then it's still going to go the same direction and magnitude. So I don't need to worry about changing these second two parameters, just where it's starting, because these second two are the direction and magnitude. So let's go ahead and run this now. And there we have it. Now you can see the addition of those two vectors. Starting at this point 0, 0, here is my vector v1, and then starting where that head is, there is my vector v2, which you can see is indeed the resultant vector r. And there we go. That's how you plot and visualize the addition of two-dimensional vectors. I want to make a quick note before moving on that if you were to then add a third vector in, you cannot just take the second vector and set it as the new origin for your third vector, because remember, those first two parameters are your starting point, which is not necessarily the coordinates of the vector itself. It worked out in our first case because we were starting at our origin, we know we would wind up at 2, 3. But if you added a third vector in, the head of vector v2 is currently at the point 2, 8. So we would need to put that 2, 8 in place of our next vector we want to add. So 2, 8 would then be its starting point, and then the vector's components, which are the direction and magnitude, starting at this point, that would be starting at the head of our green arrow depicted here. At that point 2, 8, then we can put in some vector v3, and let's make this yellow, and I'll do this out quickly. So our vector v3, I'm just going to have that go in the x direction. So we'll go 1 in the x and 0 in the y. Doing that, now we know that our resultant vector is no longer going to be at 2, 8. We added one more in that x direction, so we're now going to be at 2 plus 0 plus 1, which is 3. So now, running this, there we have it. Our third vector starts at the head, which was the original addition of the components for just the 2 vectors. That gave us that starting point, assuming that the tail of our first vector started at the origin, and then we were able to put in vector 3, which goes 1 in that x direction as pictured, and we have our new resultant vector r. And this video may have been a little bit longer than the other Python pops, but I wanted to show this example at the end of adding 3 different vectors. As always, don't forget to like, subscribe, and share. Happy learning!